So x1, x2, xn IID uniform theta minus half to theta plus half. Theta belongs to capital theta, which is same as whole r. So what is my x, which is x1, x2, xn, has PDF, let us say f theta of x1, x2, xn, which is product of marginal. So I look at marginal, it is 1 upon b minus a. So theta plus half minus theta minus half, which is 1. And then provided each xi is between theta minus half to, so that means provided xi minus theta is lies between minus half to half for I is equal to 1 to n, 0. Otherwise, I have to find the MRI of theta under the additive group of transformations. So which is same as clearly f of x1 minus theta, xn minus theta, x belongs to Rn. And what is my form of f? So my f of t1, t2, tn is nothing but, I just put xi minus theta as t over here. So this is 1 if minus half less than or equal to ti less than or equal to half for I is equal to 1 to n, 0 otherwise. So this is a known PDF, and my joint PDF is of the type f of x1 minus theta, x2 minus theta, xn minus theta. So it belongs to a location family which is invariant under additive group of transformations. I apply all my invariance principle. Now note that here the minimal sufficient statistic is x1, xn. So it is again 2-dimensional. Which is not complete. You must have done that in your last course. So that means I cannot exploit Basu's theorem to get an estimator of x1 and xn and make it independent of d. So first I try to look at what is a reasonable. So certainly I would like to use a reasonable estimator based on x1 and xn. Now note that it is theta minus half to theta plus half. x1 would be somewhere in theta minus half, xn would be somewhere near theta plus half. So one choice is I make delta naught x as x1 plus xn by 2. So MRI is, so this is clearly belongs to di, right? Because minimum of x1, x2, xn plus c would be same as minimum of x1, x2, xn plus c. Maximum of x1, x2, xn plus c is maximum of x1 plus c, xn plus c would be same as maximum of x1, x2, xn plus c. Plus c become 2c, that becomes c, so it becomes delta of x1, x2, xn plus c. So it is invariant, you can just straightforward to see. Certainly, I cannot use the Basu's theorem, so I know that MRI is delta naught x, which is nothing but x1 plus xn by 2. Let me put my loss function over here. So the loss function given is L theta A, any general loss function of the type W of A minus theta, where W is convex and even. So that is given to us. So this minus u star of d, where for fixed d belonging to Rn minus 1, u star d minimizes psi of c, which is same as expected value under theta is equal to 0 of w of x1 plus xn by 2 minus c, given that d is equal to d. So that means you need to find out the conditional distribution of x1 to x2n by 2 given d is equal to d. So what I try to do is, given d is equal to d, I try to write down what is x1 plus xn by 2. So what is given to you is x1 minus xn is given to be d1, because d1 is given to be small d1. x2 minus xn is given to be small d2, because second component is given to be small d2. xn minus 1 minus xn is given to be dn minus 1. That is what is given to you. So first I try to write down x1 in terms of d1, d2, dn. So x1 is minimum of x1, x2, xn minus 1, xn, which is same as minimum of d1 plus xn, dn minus 1 plus xn, and then xn. Now this xn is common to all of them, so I can write down this as minimum of d1, d2, dn minus 1, 0 plus xn. By the same logic, xn would become maximum of d1, d2, dn minus 1, 0 plus xn. Same way. So let me call this as d1 star, minimum of d1, d2, dn minus 1, and sorry, this would be xn, and this as dn star. So what do you get from here? Your psi c becomes expected value under theta is equal to 0 of w of x1 plus xn by 2. So this xn would come together. So xn plus d1 star plus dn star by 2, given that d is equal to d. There is somewhere minus c also. Now, what I'll do is I'll just give you a hint. You can find this, everything depends on conditional distribution of xn given t is equal to d. So conditional distribution of xn given x1 minus xn is d1, x2 minus x2 is d2, xn minus 1 minus xn is dn, which is not easy to difficult to find it out. Using that, you can write down this. Now, I know that if my psi of c turns out to be same as psi of minus c, then I am done. Then I know that minimizing, because w is convex, so my minimizing c would be 0. And so my MRI would turn out to be x1 plus xn by 2. So the only thing I need to show is psi of c is same as psi of minus c. If I am able to do to show that, then minimizing c is 0, and this would be thing. So how do I show that? So what I try to show is I try to see what is psi of minus c. psi of minus c is same as expected value theta is equal to 0 of w of xn plus d1 star plus dn star by 2, and minus c becomes now plus c, given that d is equal to d. But w is given to be even, so this is same as theta is equal to 0, w of minus xn minus d1 star plus dn star by 2 minus c, given d is equal to d. Now, if I can show that this is same as, I replace this by xn plus d1 star. So, this if I show that this is same as I am putting a question mark over here. If I can show that, then this is psi of c. Psi is convex because w is convex. I can take the double derivative with respect to c. It is a convex function of c. So, psi of 0 will always be greater than or equal to psi of c, the way we did it for the normal distribution. So, minimizing thing would be, because psi of 0 you will write down as psi of half of minus c plus half of c. Sorry, psi of 0 is same as this, and psi is convex. So, this will always be less than or equal to half times psi of minus c plus half times psi of c, but psi of c is same as psi of minus c. So, this becomes psi of c for any c. So, psi of 0 will always be less than or equal to psi of c for any c. So, minimizing thing would be 0, provided I can settle this question mark. Now, note that this question mark would be settled if I can show that conditional distribution of this given d is equal to d has the same distribution as this. So, what I need to show is under theta is equal to 0, xn plus d1 star plus dn star by 2 has the same distribution as that conditional distribution of this given d is equal to d has the same distribution as minus of xn plus given d is equal to d. Now, which should not be very difficult, because I know under theta is equal to 0, joint PDF of x1, x2, xn is nothing but how much? It was 1 if each xi lies between minus half to half. So, I first try to find out what is the joint PDF of xn and d1, d2, dn minus 1. So, my x1 minus xn is d1, x2 minus xn is d2, xn minus 1 minus xn is dn, and let me put xn as t, so that I find out the joint PDF of d1, d2, dn minus 1 and xn at point small d1, small d2, small dn minus 1 and t. So, what does that mean? That means x1 is same as d1 plus t, x2 is same as d2 plus t, xn minus 1 as, sorry, this would be dn minus 1, dn minus 1 plus t, and xn as t Jacobian would be half, sorry, Jacobian would be 1 because of the linear transformation. So what do you get? So joint PDF of d1, d2, dn minus 1 and xn is, right, f of, let me write down this, h of d1, d2, dn minus 1 t. Density was constant, so it remains constant. Each xi is between minus half to half. That means di plus t is between minus half to half for I is equal to 1 to minus 1. So minus half di plus t for I is equal to 1 to n minus 1. And t is between minus half to half. So I have to find the PDF of xn given d1, d2, dn minus 1. So that would be proportional to the joint PDF, because you know that conditional PDF is always proportional to the joint. So let me write down f of xn given d at the point t and here d. This would be some constant of proportionality which may depend on this d, because here d is fixed. So it is proportional to joint PDF. So joint PDF is this, so which is 1. And as a function of t, because d is fixed, so this says t lies between, so di plus t is greater than or equal to minus half. So that means minimum of these is greater than or equal to, that means t is greater than or equal to d1 minus half, minus d1 minus half. And each ti is less than or equal to half, so that means dn plus t is less than or equal to half, so half minus dn. And t lies between minus half to half. In fact, this can be written as C of d. Now note that d1 was minimum of d1, d2, dn minus 1 and 0. Right. This d1 is only minimum of d1, d2, dn minus 1. So 0 is not there. So this, if you want, you can write down these are d1 star, right? So this is same as cd if t is greater than or equal to d1 star minus d1 star minus half less than or equal to half minus dn star. Now using this, now you can show it. It's a simple two. So what so I did a couple of exercises over here. Now in this case, x1 plus xn by t, and given d is equal to d, if you have to find out, let us try to see. Or let me just stop over here. So what I was trying to suggest is, if one has to look at the distribution of x1 plus xn by t given d is equal to d. So what I try to do here, I am, because my distribution is uniform theta minus half and theta plus half. So rather than if my distribution was uniform theta minus sigma and theta plus sigma, where theta and sigma both are unknown, then x1 and xn would have been complete sufficient, because both the parameters are unknown. So x1, xn would have been independent of any ancillary statistic. But under this model, this is not ancillary, because the distribution of d will not depend on theta, but it may depend on sigma. So what I do is I define W1 as x1 minus xn upon xn minus 1 minus xn. Wn minus 2 as x1 xn minus 2 minus xn divided by xn minus 1 minus xn, and Wn minus 1 as, let me, xn minus 1 minus xn by mod of xn minus 1 minus xn, which is basically nothing but plus 1 if this is positive. This is positive means this is the dn minus 1. If dn minus 1 is positive, and minus 1 if dn minus 1 is less than 0, which you call as signum of dn minus 1. So Wn minus 1 is nothing but signum of Wn minus 1. Now in this case I know that x1 xn is complete sufficient, and this because I have divided it by this, so this will also depend independent, the distribution will also be independent of sigma. So this is ancillary. So W is ancillary. So in this case, when you have uniform theta minus sigma, theta plus sigma, x1 xn and W Wn minus 1 are independent. Now I know that if random vectors x and y are independent, then psi1x and psi2y are also independent. If x and y are independent, then psi1x and psi2y are also independent for any function psi1 and psi2. So if I can show that d1, d2, dn minus 1 are functions of w1, w2, wn minus 1, then that would prove that x1, xn and d are independent. So try to explore this, whether I can say that d1, d2, dn minus 1 and x1, xn are independent, because if that is the case, then directly from here, that conditional expectation which you are talking about, I don't have to deal with it. I can write down that minimizing thing would be exactly expected value theta is equal to 0 of x1 plus xn by 2, and which will turn out to be 0. So that's all for the time being. So next lecture would be on scale invariant estimation. So we'll consider the scale model, and we'll see that the class of probability distributions is invariant under multiplicative group of transformations, and then we'll do exactly the same kind of things over there. So that's all for today. See you tomorrow.